Now let us discuss about the case study on digital signal processing in modern hearing aids. Modern hearing aids integrate digital signal process to enhance the speech while minimizing the unwanted noise. Right? Now let us discuss about the impact of this and then challenges and then tools and technologies what are all the used in modern DSP hearing aids. Let us discuss.
Now the introduction for DSP hearing aids. People with hearing loss faces significant challenges in the noisy environment. Difficult to distinguish the human speech and the background ambient background unwanted noise. Analog hearing aids will amplify the sound, but we could not discriminate with the useful speech, useful human speech, and irrelevant sounds. Often it leads to discomfort and a poor performance. The solution for this problem, by integrating a DSP processor in it, it can be overcome these challenges. A modern hearing aid integrates DSP processor to enhance the human speech and minimize the noise. A DSP chip inside a hearing aid allows the real-time analysis and the manipulation of incoming sound signal.
Good afternoon everyone. I am going to tell about the key features enabled by DSP in hearing aid. First one is noise reduction. Using adaptive filters, DSP algorithm continuously analyze the acoustic environment and suppress the background noise like traffic, wind or crowd chatter. Next one is directional microphone and beam forming. DSP allow the users of microphones to create directional sensitivity, enabling the device to focus on sound coming from a specific direction. Next is speech enhancement. Using spectral analysis and voice activity detection, the processor can isolate and enhance the speech frequencies. Next is personalization. The hearing aids with DSP can be configured using software to suit the user's specific hearing profile and lifestyle. And the last one is automatic gain control. The system adjusts the amplification dynamically based on the loudness of the input signal to maintain comfortable listening levels.
I'm going to tell about technical process and the impact. In technical process, there are 4 processes: sound acquisition, digitalization, signal processing, and the output. In sound acquisition, microphones capture sound waves from the environment. The second one is digitalization. An ADC converts analog signal into digital samples. In signal processing, the DSP code executes algorithm for filtering, enhancement, and control. And the last one is the output. A DAC converts the processed digital signal back to analog and outputs it to ear speakers. The impacts. The transition from analog to DSP-based hearing aids has been revolutionary. Users report significantly improved clarity, especially in complex acquisition environment. This has led to higher satisfaction, increased adoption, and better overall communication abilities for voices.
Good afternoon everyone. I'm going to tell about the tools and technologies used in digital signal processing. So to develop and deploy DSP systems, engineers use oftenly combination of hardware and software tools. Firstly, MATLAB and Simulink help design and develop and to test these signal processing algorithms. C, C++ and Python are used to program the DSP systems on computers and embedded devices. DSP processors from companies like Texas Instruments and Analog Devices are made for the fast and real-time signal processing. FPGAs are used to create custom device hardware for high speed and low speed needs. Libraries and frameworks like OpenCV and GNU Radio offer ready-made tools for processing signals and signals in the radio, audio and images.
Good afternoon everyone. I am going to talk about challenges in implementing DSP. First comes real-time constraints. Applications like audio processing, radar, communication require low latency, which places strict timing requirements on DSP system. Then comes power consumption. Portable and embedded devices like smartphones or wearable devices balance performance in battery life. Quantization, noise and error accumulation. Inaccurate representation due to fixed point, insufficient but depth can degrade signal quality. Hardware limitations. High performance DSP processor can be expensive. It is also cost effective to process trade-offs.
Good afternoon everyone. I'm going to talk about the future trends in DSP.
So first comes artificial intelligence and machine language. So under this, AIML is trying to incorporate neural networks into DSP. With this, we can simplify tasks like image and speech recognition. Next, we have edge computing and IoT. Normally, DSP relies on cloud structure, but with the incorporation of edge computing and IoT, it does not rely on cloud architecture. Then we have quantum signal processing. So here we combine quantum computing and signal processing, which makes the DSP processors more efficient for all the tasks. Then we have 5G and 6G technologies. So these are next generation technology which help for faster processing, and it also makes the processors more efficient and more intelligent.
So I am going to conclude the case study. Digital signal processing is a fundamental technology that has transformed the way we interact with the world. It allows for the more intelligent systems, greater automation and real-time insights in virtual every field of engineering and science. As DSP continues to evolve, its impact will expand even further, enabling innovations in healthcare, communication, entertainment and beyond. Thank you.